All right, here we go with example 2. So we know that triangle WTZ is isosceles with base WZ. So we can go ahead and mark TW congruent to TZ. Because if this is our base, then the other two sides are the legs. We know that angle 3 is congruent to angle 4, and that TB is congruent to TA. Now we're trying to prove BX congruent to AY, so if I can get these two triangles congruent, then I will be able to say by CPCTC that BX and AY are congruent. So starting with the given, we have our isosceles triangle. We have angle 3 congruent to angle 4 and TB congruent to TA. And then we said that TW is congruent to TZ because if isosceles, then the legs are congruent. And then we can say that BW is congruent to AZ, and that's going to be by subtraction. Because we know that we have TW minus TB equaling BW, and TZ minus TA equaling AZ. We had those the first two congruent in step 2, and the second set of segments were congruent in step 1, which makes BW and AZ congruent. So now we have an angle and we have a side of those small triangles at the bottom. So now we would either need another side, which we can't get because that's what we're trying to prove, or we need to get these angles, angle W and angle Z. And we actually can get those angles by one of our new theorems, because if it's isosceles, then the base angles are congruent. At this step, you also could have said if two sides are congruent, then the base angles are congruent, because you did prove the two sides in step 2. Okay. So now in step 5, I can say that triangle BWX is congruent to triangle AZY because of angle, side, angle. Finishing this proof in step 6, we can say that BX is congruent to AY by CPCTC. Moving on to example 3. We know that angle E is congruent to angle H, and segment EF is congruent to segment GH. Now we're trying to prove that triangle DFG is isosceles. So if I could get these two triangles on the sides congruent, then by CPCTC, I can get DF and DG congruent, which will make an isosceles triangle. All right, so I see that I have an angle and a side already in my proof. So I can't prove these two sides, and I don't know anything about these angles down here. But we can use our new theorem to get DE congruent to DH. Because if the base angles of a triangle are congruent, and that's true in triangle DEH, that the base angles are congruent, so then I can say that the sides opposite them are congruent. So if the base angles are congruent, then the sides opposite them are congruent. So now I can say that triangle DEF is congruent to triangle DHG by side, angle, side. By CPCTC, we can say that segment DF is congruent to segment DG. And then we can say that triangle DFG is isosceles. And our reason will be if two sides of a triangle are congruent, then it's isosceles. All right, moving on to the next example. I want to look at the relationship between the sides and the angles. So when we look at the sides, the lengths are marked here, and our biggest side is CB, which is 5.17. And the smallest side is AC, which is 3.92. So that makes our medium side AB. And then the biggest angle is angle A, which is 72.57 degrees. And the medium angle is angle C, which is 61.06 degrees. And then our smallest angle is angle B. All right, so now let's look in the diagram at my biggest side here and my biggest angle. Do you see that they're across from each other? And then let's look at our smallest side, which is the 3.92, and our smallest angle, which is B. And you just see that they are across from each other. And that held for the biggest side as well. Both were opposite each other. So that leads us to what's known as the inverse isosceles triangle theorems. And it says that if two sides of a triangle, so let's look up here. What is the inverse of if P then Q? The inverse is if not P, then not Q. So then the inverse of if two sides of a triangle are congruent, then the base angle is congruent would be if two sides of a triangle are not congruent, then the angles opposite them are not congruent. So then that means the inverse isosceles triangle theorem talk about not only the fact that they're not congruent, but also the size relationship. So if two sides of a triangle are not congruent, then the angles opposite them are not congruent, and the biggest angle is opposite the biggest side. And then again, it goes the other way with the angles. If two angles of a triangle are not congruent, then the sides opposite them are not congruent, and the biggest angle is opposite the biggest side. So now we're going to look at example 4. We want to list the sides in order from smallest to largest. So take a second to try to do that. So the smallest side is going to be opposite the smallest angle. So the smallest angle is 27.63. So the side opposite that is AB. And then the medium angle is 73.85, and the side opposite 73.85 is AC. And then finally we have angle A is the biggest one, and the side opposite that biggest angle is segment BC. So in order from smallest to largest, it's AB, AC, and BC. So now we're going to do a restrictions problem. So we know that AC is bigger than AB. So that means that this side is the big side and this side is the small side. And then I know that the measure of angle B plus the measure of angle C needs to be less than 180. And I know that angle B is 6x minus 45 and that angle C is 15 plus x. So then there are two things that I can say. First of all, I know that because this angle is opposite the biggest side, that 6x minus 45 needs to be bigger than angle C, because that's opposite a smaller side. And then the other thing I know comes from the second inequality. I know that 6x minus 45 plus 15 plus x needs to be less than 180. So those are the two inequalities that I can write, and these are going to help me find the restrictions on x. So go ahead, take a minute, and solve the two inequalities. So when we solve the inequality on the left, we get that x is greater than 12. And when we solve the inequality on the right, we know that x is less than 30. You can combine those into one statement. We know that x needs to be bigger than 12, but it needs to be less than 30. And those would be the restrictions on x. All right, so then the last example asks us to name the angle with the smallest measure in triangle LNM. So looking up here at this top triangle, we see that the sides are 10, 7, and 6. In this triangle, the smallest side is 6, even though it doesn't look like it. So then that means that the angle opposite it is the smallest angle. So this one is going to be angle N. The next one asks us which angle in triangle MOT has the largest measure. So the angle in triangle, let's look at the angles in triangle MOT, that's the triangle in the bottom. So then we've got 5, 8, and 9. So the largest angle is opposite the largest side, so that's going to be angle T that's opposite from the one that's the biggest. All right, so now what we want to know in the last question, and this one's a little tougher, is which of the 6 angles in the 2 triangles is the largest? Now, if I just use the inverse isosceles triangle theorem, I know that in this top triangle, this is the biggest angle. The 7 is the medium angle, and the one across from the 7 is the medium angle, and the one across the 6 is the smallest angle. And then in the triangle on the bottom, angle T is the biggest angle because it's opposite the biggest side. Angle O is the smallest, and angle 2 is the medium. But because angle 1 and 2 are vertical angles, I know these two are going to have the same measure, but I know that this angle T is bigger than angle 2, and so that makes it also bigger than angle 1. So in the 6 angles in the 2 triangles, angle T is the largest.